Hello YouTube, around the side. So in today's video, we will be discussing how we can connect our EKS pod or pods running in our EKS cluster to AWS services using IAM roles for service accounts. I have already created a video for the same approach using EKS pod identity. So you can check out my previous video related to the same. And in this video, we will be going through how we can use IRSA for connecting our AWS services with the pods. So IRSA stands for IAM rules for service accounts, and it is an AWS feature that enables fine-grained control over your permissions for applications running in Kubernetes. Specifically, in today's case, it's Amazon EKS. So by assigning AWS identity and access management, aka IAM roles, to Kubernetes service accounts. This eliminates the need to rely on node-level IAM roles and making your setup more secure and manageable. So in short, we can understand that we will be creating specific IAM roles which we will associate with our service account, and that would be utilized to connect our pods with AWS service. So key components for IRSA. So these three are the key components which we will be understanding, and in the demo also we will go through it. So first component is Kubernetes service account. So a service account in Kubernetes is used to provide an identity for a pod or group of pods to interact with a Kubernetes API or other services. So in short, we will be creating a Kubernetes service account which will help to identify which pod or group of pods should interact with the Kubernetes API or the services. After that, we have IAM role. So IAM role is nothing but a simple role where we will be giving the permissions or the set of permissions, and using IRSA, we will associate the IAM role with the service account by giving specific pods permission to access AWS services. After that, the third component is OIDC. So this is a new, or you can say a distinguished component as compared to EKS pod identity. So in IRSA, we will be using OIDC, which stands for OpenID Connect, identity provider. So here, IRSA uses an OIDC provider to establish a trust relationship between the cluster and AWS IAM. This allows AWS to verify the identity of the Kubernetes service account. So OIDC will act as a mediator between our Kubernetes cluster and AWS IAM by providing a trust relationship. After that, let's learn how this IRSA works. So first is OIDC setup. So first we will set up the OIDC by, as soon as we have created a EKS cluster, then an OIDC identity provider URL is also associated with the cluster, which I will show you where we will be getting this OIDC URL. So that OIDC URL we have to configure IAM to trust this identity provider. After that, we have service account and IAM role association. So here you create a Kubernetes service account and annotate it with an IAM role. And this annotation links the Kubernetes service account with a specific IAM role. So in this, what we will be doing, we will be just creating a service account YAML file in the Kubernetes, and we will be adding an annotation after we create the IAM role. This annotation links the Kubernetes service account with a specific IAM role. After that, authentication flow. When a pod uses the service account, it automatically inherits the permissions defined in the associated IAM role And then AWS validates the identity of the service account via the OIDC provider. Temporary credentials. The pod does not need static AWS credentials. Instead, it receives temporary credentials from the IAM role, which are rotated automatically. So we don't have to configure anything if we have done all the previous steps. So you should also ask why we should use IRSA. So first answer could be fine-grained access control. Then we have improved security as well because we are eliminating the need of AWS credentials as we are not storing or configuring those inside our cluster. So we are improving security. After that, we have simplified management and node level roles like an EC2 instance profile are no longer necessary for pod access to AWS resources, making permissions easier to manage. And last, we have least privilege principle. So each pod can operate with the minimum permissions required, adhering to security best practices. So this was the benefits, or you can say why we should use IRSA. And now we have a simple architecture like how the OIDC or IAM role for service account works. So in my previous video also, I have used the same type of flow, and the credit goes to the respective owners. I don't own this image. Okay, so here you can see that we have a Kubernetes pod and it is associating with a service account. And here with the numbering or with the labels, we can understand that our pod is connected with service account and then our service account is connected with OIDC, which we will be getting from EKS cluster. Then that OIDC will be associated with our service account and we will be using AWS IAM role, by which my AWS IAM role plus OIDC will help my service account to get or to to establish a trust relationship between our cluster and at the AWS cloud. And after the trust relationship is established, then the same details which is asked by pod from accessing or from getting some resources in AWS cloud, then it could be easily possible. So this is a small presentation I have created for this demo, and I have heavily taken help from the official documentation also, and I will be like giving this URL in the description also of this video, so you can also go through this video. Sorry, go through this documentation if you need more details. Just for simplicity and to make things easier, I have uh, already created the steps in my GitHub repository in smaller steps so that you may not get confused and everything can be easily fetchable for you if you are like following the same thing in your site. So I will be taking the similar application, means a similar YAML manifest file which I have used in my last video as well, where I have explained EKS port identity. So I will be not like mentioning anything about the YAML. It's just a simple deployment YAML and a service account YAML, and I'm just using a different namespace test, and everything will be done there. So the main thing is the README file which I have created. So if we go step by step, what we have learned till now from the presentation and from the flow diagram. First, what we will be doing, we will be creating an OIDC identity provider for the cluster. So for creating that, we will be using this command where we are associating the IAM, like we are associate IAM OIDC provider, and we are giving our EKS cluster name as the parameter, and we are approving this, and we are mentioning where the cluster is resided. After that, we are creating a policy where we will be describing that my pod should have these type of actions, and these actions should be specific to these resources. So here in this case, I will be using a S3 bucket, and these are the actions which I want to perform in this S3 bucket. So after creating my policy, I have created a trust relationship JSON file. This JSON file is already there inside this documentation as well. So you can also check, or you can replicate the same according to your needs. I think it is okay. I think it should be, yeah, here. So here I have used the same JSON file, but I have modified some parameters because my namespace, my service account, and all other stuff are not similar to here. So that you have to take care if you are performing the same. So this is the trust relationship JSON file. After that, we are creating a role and appending this trust file. So we are creating a role using AWS IAM command, and here we are also giving this trust relationship JSON file as the parameter, and it will associate with the role. After that, after creating the role, we are attaching the role with a policy, with this policy we created for the S3 bucket, and this is the command to use that. And after that, we are creating an annotation in the service account, like where we have to use. So this is the kubectl command for adding or appending the annotate to the service account. So I hope I'm able to make the things clear till now. Don't worry, I will be like also showing the demonstration for the same. So I have already created a EKS cluster using EKS CTL, and I've also already mentioned the steps I have used for creating this EKS cluster in my previous video as well. I will be also mentioning the GitHub repo if you are okay with that. So kubectl get nodes will list down the nodes I'm using for this Kubernetes cluster. So I'm using two cluster. And if we go according to the README file, first we have to create an IAM OIDC identity provider. So for that, first let me also show the OIDC Connect provider URL. So this is the OIDC Connect provider URL, which will automatically associate it when you created a Amazon EKS cluster. And if I go to my IAM, let me duplicate this tab. So in the IAM, inside identity provider, here we can see that no resources are getting displayed. So using this command, we will be creating a OIDC provider for our EKS cluster. So let me just copy this command and paste it here and execute it. So it has created the IAM OIDC provider, and let us see if it is created inside identity provider or not. Let me refresh this and see. Here it has created this provider. If you will see that this is the ID of my cluster, and it is starting with 9F502, and here also you can like verify that it is it has correctly created the provider URL. Okay, after that, we have to create a policy. So I will be directly copying this and going back to the IAM and click on policy, creating policy. So I will be selecting JSON because I already have the JSON format with me, pasting it and clicking on next. And for the hard coding purpose, because I have already hard coded the steps, so I will be using this name as well. But you can use any name according to your need or your requirement. Um, Let me give this, okay, create policy. So I think policy is created, IRSA, yeah, the policy is created. After that, we have to use this trust relationship JSON file. So I will be copying this. So here, let me explain you a little bit in a depth. So here, what I'm doing, we are just creating a statement and we are giving allow effect to the principal. And in the principal, we are mentioning the OIDC URL or the ARN. After that, we are mentioning that this action, which is assume role with web identity, should be attached to this policy where OIDC is this and OIDC provider should be using this service account which have the namespace test and the service account name should be this. So I will be copying this and I have to do some modification because this has different OIDC ARN and it has some uh, variable, environment variable. So I have already explained you that I have copied or taken everything from the official documentation. So I will be like modifying the same according to my cluster. So the name is, let me use this and copy this. So what things we have to modify here? Let me show you. First of all, we have to modify the ARN. So I will be removing this ARN. Okay, I think, yeah. So now what I will do, I will directly go to my cluster and will take the ARN of my OIDC provider. Okay, for that I should go back to IAM, then identity provider and select this. This is the ARN value. Paste this. After that, I have to change this environment variable OIDC provider and it should be this. After that, the same value should be given here in the audience and this subscribe. Okay, now save this and get out of from this file. After that, as we have created the trust relationship JSON file as well, So now I will be creating a role and appending or like attaching this trust policy with the role. Let me copy this and hit enter. So this role, which is role IRSA demo, should be automatically created inside my IAM, and it has provided me this JSON format. So I think everything is correctly done till here, and we can verify that if the role is created or not by going to the IAM. Then the role name should be role IRSA demo. Let us take that and enter. So see, this role is created, and inside trust relationship, we can see that it has taken that file which we like created just before, and it has used that trust relationship. Okay, after that, we have to attach the role with the policy we created. So I will be using this command, then hitting enter. Okay, so I think the role is also done. Now some Kubernetes stuff we have to do. So first I will create the namespace test kubectl create ns test, and now I will directly using the YAML manifest which I have created. First I will be using the deployment manifest, nano deploy .yaml, paste this, save this, and get out of this. After this, I will create a service account YAML. Okay, so I will apply my SA file as well as my deployment file. So both are created successfully. After that, I will go back to the README file. And now what I will do, I will append the annotations in the service account which we have to use. So I will directly copy this and I will paste it, and let me hit enter. So service account nginx -sa is annotated correctly. Okay, so we have correctly done all the steps, and with the flow we can say that my AWS IAM role as well as policy is created correctly, and our OIDC provider is also attached with this role using the trust relationship, and we have annotated our service account as well after this, and my Kubernetes pod is also connected with the service account which is nginx-sa, and now we will try to access AWS S3 bucket inside our pod. So let us check the pods. kubectl get pods -n test. So our one replica of the pod is running. Let me first clear this. kubectl get pods -n test. Okay, so now we will move inside this or SSH this pod using exec command, and let us take this name, then --bash. Okay, so now we are inside this pod, and let us first update the pod or the container. Okay, the pod is updated. Now let us install AWS CLI. For that, apd update AWS CLI -y. AWS CLI For the bash, I guess, let me install with snap then. Install AWS CLI -y. Um, by using this, it is not giving me. Um, okay, I think I need to check. Install AWS CLI bash. For the Linux, okay, apt install unzip -y. Okay, and after that, I just have to use this command for moving the unzipped content inside the bin folder. Okay, now let us check if AWS CLI is installed correctly or not. Okay, so CLI is also uh, done correctly. AWS S3 LS. Okay, so I think as we have not given permission to list all the buckets, we have just given a specific bucket to get accessed. So maybe let us try with this. Um, AWS S3 LS, then the bucket name. Is not authorized to list bucket on. Okay, now I think let me do one thing. Um, as I have not given all the list permissions, let me try to upload some stuff from inside my pod, and let us see that will it upload the same on S3 bucket or not. So let me just create a small file, and I know, okay, just a one-liner file, maybe echo file created and written from the pod hello.txt. Okay. Um, okay, so this line is appended to this file, and let me AWS S3 copy this file to our S3 bucket, and the bucket name is EKS. Okay. Is not authorized to perform because not already S3 put object action. Let me check. According to this policy, we have already given put object. Let me edit this and give more permission. Okay, S3 and list access grant we can provide, and for put read and write. Um, okay, put object. Let us save and let's see if this updated policy will work or not. An error access denied when calling user ARN is not authorized to perform S3 put object on resource EKS because no identity page provided allows the S3 put object action. Okay, let me do one thing then. Um, I don't want to make this video longer, so just for the simple purpose, I'm giving full S3 access and let us try now. Okay, next, and save the changes. And now let us try AWS S3 LS. Okay, let me clear this. LS. Okay, I think this is the command which should be okay. AWS S3 copy, um, then dot, and now let's try. Because no identity based policy allows. Okay, now edit. Fix the syntax. Let me. Okay, and now check our resource. Now let us give all. I'm not sure what is the error. Now save changes, and now let me try again. Let me try to kill this pod and kubectl get pods. Sorry, -n test kubectl delete pod and -n test kubectl get pods -n test. Okay, so now this is the pod ID now. Kubectl exec -it-n test, then this and bash. So okay, I think I have to again create this echo echo file created and content written inside the pod for AWS S3. hello.txt. Okay, AWS S3 LS. Okay, now I think I have to install AWS CLI apt install unzip -y. Let me give sudo then apt update -y apt install unzip -y. Okay, and then AWS CLI. Okay, sudo is not found, no problem. Let me do this. Okay, now list down the S3 buckets. Okay, so now it's running. And now I also understood my issue, as I have not updated my or like deleted the pod. So it was like not updated with the updated policy. So this is why we were getting the same error every time. But now, as I have already given the full access for all the resources and all the actions, so now we should not face any issue in uploading the same. So now we will use AWS S3 copy command, and we will be moving the this file to the bucket, and the bucket name is this EKS bucket IRSA demo. Okay, so now no error and uploaded our text file to the bucket. Now let me refresh this, and we should see the hello text file. Okay, let me download this, and here you can see file created and content written inside the pod for AWS S3. So this is how we can utilize IRSA. And sorry for making this video longer, because for some issue, and like I forgot, like I should have deleted the pod first and updated my policy. So yeah, you don't need to like give full permissions inside the policy. So you can go accordingly. And I hope I was able to make things clear here. And now you can decide like which approach is better for your requirements and for your needs by connecting your EKS pods to AWS services, like using EKS pod identity or by using IRSA. So thank you all for your time, and have a nice day. Thank you.